Okay, so today we're just going to have a quick overview of acids and bases, their definitions, and how they can be measured. So one way of defining an acid is the Bronsted and Lowry definition. This says that an acid is a proton donor, whereas a base is a proton acceptor. Looking at an example of a Bronsted and Lowry acid, we have hydrochloric acid with water. And the hydrochloric acid is donating a proton to the water. So in this case, the hydrochloric acid is the Bronsted acid and the water is a Bronsted base. The products of the reaction are known as its conjugate pairs because we can represent the chlorine ion as a Bronsted base and the water ion as a Bronsted acid. The definition is not specific of a certain species but specific of a reaction. So if we look at ammonia and water, here ammonia is accepting a proton, so it's the Bronsted base, and the water is donating a proton, so it is the Bronsted acid. Another way of defining acids is through the Lewis definition. Here we say that a Lewis acid is a species which accepts a lone pair of electrons, and a base is a species which donates a lone pair of electrons. The best example of this is in the form of complexes. So here we have a chromium ion and water, which is going to act as ligands to form the complex CrOH2 6. So how do we measure the acidity? One way is through Ka, and this is called the acid dissociation constant. So if we look here for ethanol, Ka is measured as the concentration of CH3CH2O- ion times by the concentration of H+ ion over the total concentration of the ethanol. Sometimes you might see acidity described by pKa. This is just minus log to the Ka. So for a strong acid, you're looking for a high Ka value or a low pKa value.